Okay, so what's next? Well, let's actually play the full game for real now. We've got our play one game for student function, right? Let's play one game, right? So we need to make another function for this, or it will be handy to at least. I'm going to do that. Function play one game. And this is just going to take the boxes itself. That's all it really needs to know, right? Based on the number of boxes, I know how many students there are, right? If there's 100 boxes, there's 100 students. So I don't need to know the student number like I did down here because I'm not playing for a specific student. I'm about to play for all 100 students in this case. So that's the only input to this function. Sounds good? Okay, so let's actually grab that value out. I'm going to actually make a variable here. I'm going to explain why. It's just for style reasons. Let num students, whoops, I can't spell, students equals boxes.length. Just like we did before, we used boxes.length. But notice I'm using it in a very different way than boxes.length is normally used. Boxes.length normally says, how many boxes do I have? It's up to us as the designers of this game or the writers of the code to know that the number of students is the same as the number of boxes. That's just the same. It's a little awkward if we start using boxes.length directly where we mean number of students without calling it number like num students or something that is obviously the number of students. So again, this is just me reminding myself that no, the number of students is the number of boxes. And I'm going to use num students down below in this function where I mean number of students, not number of boxes. And therefore, this helps me keep my brain a little bit more straight that I'm doing the right thing. Otherwise, I might be like, why am I counting the number of students by the length of boxes? And then have to remember what I'm up to. So, yep, this is just kind of a nice, handy way to make your code read a bit more like English. So, okay, so we got a variable. Let's make our for loop. What are we doing here? Well, I want to go through every student, right? I want a for loop that says start at student 1, go all the way through student 100, and play this one game for this student, right? With the same boxes. Okay, sounds good. Let's start the loop and we're going to say let s equals 1, start at student 1. S is less than or equal to num students. Notice I'm doing the non-zero counting one because I actually do, in this case, prefer the student number to start at 1. That's the student number we're looking for in the box, right? The numbers in the boxes are 1 through 100, not 0 through 99. The positions are 0 through 99, but the numbers themselves were 1 through 100. So just to save myself some math, I am saying, you know what? Student numbers are always 1 through 100. I don't want computers to dictate the way I number my students. So this is, again, a complete choice for you as the programmer. You can do it either way. You just have to make sure things are consistent. So, and then, of course, I'm going to go up by 1 each time like usual, curly braces. So this is going to loop 100 times, right? Let s equals 1, s less than or equal to number of students, which if number of students is 100, going up by 1, 1, 2, 3, 4, 5, all the way to 100. And then 101, this condition fails and the loop ends. Sounds good. And like we said, the only thing we really want to do in here is just say, well, we want to play this game for one student, right? Play one game for student. The student number is S. I happen to choose my variables to be exactly the same again. Again, not because they have to, but because I guess I'm lazy. Hope I'm not too lazy. Anyway, we'll see. S comma boxes is what I'm going to send in here. So again, this just kind of passes through the boxes variable to this function. It's the same set of boxes for every student. So nothing has to change there. But notice S is changing every time we call this function, right? Put my semicolon here for the moment. S is 1 on the first shot, then S is 2 on the second shot, which means we'll be comparing to see if they find the number 2 in the box contents, and so forth. When this S is 7, they'll be choosing 50 boxes and seeing if the box contents are 7. So that's cool. What do we do with this? We called the function, but it returns a 1 or a 0, and we haven't done anything with it yet. Well, what do I want to do if it's a 1 or a 0? If it's a 1, yay, they won. That's happy. If it's a 0, they lost, and that means we shouldn't even really bother with having more students play the game, right? If one student goes in, chooses half the boxes, and they fail to find their box, the game is over. Everyone has lost, sadly. Okay, so really I want to take action on 0 for sure here. If it's a 1, we just keep playing the game. The for loop continues. But if it's a 0, we want to stop. So that's what I'm going to do. I'm going to say if, and I'm going to put some brackets around this. I'm going to get rid of my semicolon. That's why I said I was putting it there for the moment. I want to actually say if this is equal to 0, if they lost, do something. So again, there's only two shots. There's only two possibilities here. They either return a 0 or they return a 1. If they return a 0, we need to just say, sorry, that like game is over. And if they won, well, then we don't do this code here. It just tests the condition. It's equal to 1, so this is false. It jumps down here and just continues the loop. So the next student plays, which is what we want. They found their student number in the first 50 boxes. Let the next student go in and try. And this just keeps happening until either one student fails or we get down to the end of the loop. And that means every student won down here. Okay. So what are we going to return from this function to be useful? I say be useful because we could just return again a 0 here saying, sorry, we lost the whole game. Or we could return a 1 here if we won the game. That's totally fine. That would be fine. I'm going to return just a little bit more information just to be interesting. We'll use it later, but it's sometimes useful just to return some statistic of what just happened. This could be useful for tests or error checking or probabilities or things like that. We'll use it for probabilities. I'm going to return the number of students that had won the game before the first student lost. Okay, so here we have a return something, question mark, and down here, well, all the students won, right? We're just going to return num students, right? That's how many students just won, were able to find their number, 50. In this, or sorry, 100 in this case, right? 100 students just opened 50 boxes each. Every one of them, if you've gotten down to this point in the loop, found their right number. So let's just return number of students. Otherwise, well, let's say S was 7 right now, and 7 lost. They were like, oh, I didn't find my number in my 50 boxes. So how many students have won so far? Well, 6, right? 1 through 6 played their game, succeeded, but then 7 did not succeed. And so 6 have actually won. So anytime S loses, we have S minus 1 successes before that, right? So if it was 7 that lost, it's 7 minus 1, which is 6 people that have won. If it was 72 that lost, then 71 people before them have won. And that's what we're going to return. Again, this is slightly more complicated than it needs to be for now, but it does give us some statistics on how many students actually made it through before they lost, or did all the students make it through. Notice, importantly, though, it still gives us exactly the information we needed. If we go back up here to where our function call is, we're going to change this from play one game for student to just play one game, right? We're going to call our new function because we want to play an entire game. That was just a placeholder to play for one student. I'm going to get rid of the 1 here because we're actually playing with all the students now, right? This only takes the boxes and plays 1 full game with all the students. And this returns the number of students. Now notice that wins is not going to be right, but we can easily determine if they won, right? If the number of students returned is the total number of students, then they won the game. If it's anything less, they lost. So we can still figure out whether they won or lost. But for now, we're just going to actually report on the number of students that won overall. So even if they lost the game, we're going to say, well, 71 students won, but the 72nd lost. But then, if we ever got to 100, if we got 100 students won, well, then they actually really won the game. So we'll fix this we'll fix this text message in a bit to actually report the number of real wins. But for now, just so we can see what's happening, we'll report just the number of students that even partially won. So now we try out our game. Click run. Okay, 1, 0, 1. I'm just clicking this much time. 1, 0, 100. A bunch of zeros. Something is wrong, right? This can't possibly be right. We had said that if you played the game for 1 billion years once a day, you would still have more chances of winning the lottery twice in a row than having seen 100 students win the game. Also, the number of zeros I'm getting now is alarmingly high. Sometimes at least one student should be getting through, right? This should have been a number between 0 and 100 of how many students got through, guessing 50 boxes and finding their number before somebody failed. So something's wrong, and you might be like, oh, is my code wrong? I mean, obviously it always can be. In this case, it turns out to be something very strange. So I'm just going to go over here, click on console, and there's this secret little warning here that's been popping up a lot, and basically just says, we've only stored the 10 last messages, just FYI. An infinite loop, or a loop taking too long, focus on the latter one, was detected. So we stopped its execution. More details here. They're trying to protect us from ourselves. If we wrote a loop that never stopped, this whole tab would probably just hang, and you'd have to kill the tab. So to protect you, CodePen actually tries to be nice and says, you know what, we're going to by default limit your for loops to a very short amount of time. If they don't finish in that amount of time, we'll just say they probably are, hung, they might never exit. We're going to give the browser control back and just stop running them. I have no idea how that possibly results in a 100 showing up. I don't know what happened there, but this is clearly messing with our for loop. They are stopping our for loop mid-run, and I guess returning something. Sometimes 100, apparently. So if we go to this link, let's just go see what they say. Hopefully we can fix this. We can. So you can adjust the infinite loop protection timing. Yay. Thank you, CodePen. You are very kind to us. So this is what they say. In some rare cases, it stops loops. That it shouldn't. More of an art than a science. That is true. They picked some magic timing numbers. 2.2 seconds. I'm a little surprised our loop ran for 2.2 seconds. If you think about it, we did 100 students, and then within those 100 students, we ran each of them picking 50 boxes up to. So that could have run up to 5,000 times, but it probably was a lot less. After the first few students, it probably failed. So I'm not entirely sure why this tripped, but it does end up being the problem. So it says you can change the variables. You probably want to change this variable. They even helpfully give you this value that you can use to basically stop them from doing this. So we are literally just going to copy this line of code. I'm going to close this, and we are just going to shove this at the top of our file and try again. So I pasted that in there. I'm not entirely sure. I think if I kept reading, they say 6,000 is the max, and they just disable the loop detection, because our for loops can apparently run longer than 6,000 seconds with this, 6,000 milliseconds. I don't know what time this is in. Anyway, maybe it is 6,000 seconds. Maybe it'll just never run longer than an hour and 40 minutes or whatever that is. Anyway, all to say, let's try running it again and see what happens. And I'll clear my console here. Whoops, wrong button. There we go. Okay, the loop is still running amazingly. Don't know why, but let's see what happens. And I'll scroll down here. This is our one game function running, play one game. Yep. And let's hit run again. Okay, it is working now. Sorry, apparently I just needed to press the, and notice there's no warnings anymore here when I press the run button. I don't know why 5,000 came up. That was weird. I think it was because it must have saved or and then just like rebooted. But basically, we're now getting much more expected numbers. I see no 100s. Yep, this is working now. Perfect. Okay, so after this line and maybe a little bit of like it figuring its life out, you have to, see like you can see a 5 in there at one point. There's some 3s, 1s, 2s. I think we've seen. There's a 5 again. So this is what we expect. A few students make it through, but it's becoming increasingly unlikely as the number of students increases that they'll actually win. Now notice if I down this to 4, you'll get 1, 2, 3. Can we get a 4? Yes, there was a 4 there. I clicked too fast. But anyway, yep, there was another 4. So in those cases, students would have actually won. Obviously, in the case of 100 students, we should never see 100 here. This should be very low numbers. Very rarely should you go up into like the 6, 7. If you see higher than that, that's pretty fortunate for those students. Certainly not 100. That would be crazy. All right. So the game is working. It's not returning the number of wins, but just the number of students that partially won the game. So let's fix that. To do that, we're going to scroll up to where we use our play one game function. Sorry, right up here, just a few lines up. And the students won is, that's how many students won before, somebody lost, or maybe nobody lost. If students won, it was 100 in this case. But what we really care about is the number of total wins, right? So I'm going to make a variable with that. Let num wins equals 0. And that's what I'm going to assign here later on. I'm going to get rid of that extra space. Instead of students won, I really want to say num wins is what I care about here. That's, after all, what I said this text actually is, number of wins. Okay, so basically, number of wins gets to be 1 if students won is 100, or in general, the number of students, and it gets to be 0 otherwise. So I'm just going to say if students 1 equals num students, again, if 100 students actually got it through this game, and that's how many students there were, then they actually won. Nobody lost. Amazing. So then I'm just going to say curly braces num wins plus plus. Just make it equal to 1 in this case. I could have just said equals 1 here, but I'm going to put this in a loop in a second, right? With the number of iterations that we're doing for Monte Carlo stuff. So the idea is that if this ever happened, the number of times the students have won has actually gone up by 1. Okay? So let's run this. Now we expect solid zeros, right? And this is as expected. There's nothing weird going on in the console except this weird syntax error that I fixed already because it's working. If I clear this and run it again, it'll work just fine. Yep, okay. So, of course, I don't expect anyone to actually have won this game. Let's down the number of students to 2. I'm going to press run a bunch of times. There we go. Got some 1s. Good gracious. That took a little while. But basically, sometimes these students actually win the game just by randomly choosing. Notice with the number of students at 2, they each go in and pick 1 box. They both have a 50-50 shot. So there's a 1 in 4 chance of them actually, like they actually have a 50-50 because there's no memory involved, even like we said before. So there's a 1 in 4 chance of them winning. And indeed, if you click this enough times, you'll probably see, yeah, okay, maybe the 1s are coming up that many times-ish. Okay, great. If I increase this to 4, the odds drop significantly. You won't see many ones at all, but they do happen occasionally. So we've got number of wins, but let's actually respect the number of iterations that we want to run. We've only been playing one game so far. We want to play 10,000 or 1,000 or 100,000 games, depending on what we type in this box. Okay, so let's go do that. Up here, I'm going to put this at the top. I want to actually grab this value, right? Number of iterations. I've got my number of students. I've got my wins tag, which was just this thing, so I could change it. Now I'm going to grab this thing. I actually care about this now. Const num iterations equals, and again, remember, it's document.get element by ID, and it's the, my semicolon here just to finish that off. Notice it's the num iterations. That's what I called this thing, right? Num dash iterations. So I'm going to say num dash iterations, just like I did up here. And because this is numeric, notice I'm going to do exactly the same thing I did with my number of students. I need to parse this as an integer, and I need to have grabbed the value to do that. So get the value of this box, not just the box itself, which is the entire HTML tag, but the actual number inside. So 10,000. And I need to actually make that a number, not text, not quote 10000 end quote, but parse int says, no, it's actually a number that I can add 1 to, subtract 1 to, count up to, things like that. Okay, so we have our variable now. This should say 10,000 or whatever we type in here. Let's scroll back down and we're going to make a third for loop. That's right. This is 3 for loops deep. We've hidden it well by putting them in different functions. But we are going to create random boxes each game, notice. Play that game, and then increment the number of wins if students 1 happens to be the number of students. Notice I don't want to keep resetting my number of wins to 0 every time. I want that to start off. The number of wins at the entire beginning of the 10,000 loops of 10,000 games should be 0. So I'm going to move that up here. And then this is where my for loop is going to be, around this code. So you can add that in. I haven't actually said anything about the for loop yet, so it's a little mad at me with this exclamation mark here. We're going to fill that in a second. But notice this part up here just says, oops, sorry, at the bottom, however many wins I had, assign that to inner HTML, right? So if I play 10,000 times and the students happen to win 5 of those 10,000 times, we'll get in here 5 times. Number of wins will go up 1, 2, 3, 4, 5, and then we'll just assign 5 to the end of it. And we'll say, okay, out of 10,000 games, we had 5 wins. Yay. All right. So here comes the for loop insides. I say insides, I mean the, what do you call it? The, how many times do we need to loop part? Let I equal 0. I is less than num iterations, right? That's how many times we want to loop. Num iterations, I plus plus. Hopefully becoming a little bit familiar now. As always, it takes a little bit of time. Okay, this says do something 10,000 times if number of iterations is 10,000 times. It just says do this, right? This was us playing one game. Created a bunch of random boxes, played one game on them, figure out if they won or not, and increment the variable if they did. So hopefully this, I can clear this now. I just want to make sure my error went away here. Yep, good, exclamation box is gone. Let's actually run this. Okay, 0, 0, 0. That's not too surprising. Not going to be very interesting unless I down the number of students and actually give them a chance to win, right? So let's do number of students 2 and see what happens. Ooh, 2457. Notice that's close to the 2,500 that we said we would expect out of 10,000 runs. There's a quarter chance of them winning this game. So if I keep going, notice sometimes it's over 2,500, sometimes it's under 2,500, but it's close. They're basically winning a quarter of the time. Let's try 4 students. Remember, we can't try 3 because if we try 3, we get the error, right? Number of students must be even. Okay, exciting. So we click 4, 385, 373, 360. Okay, that's not that many, but still not that bad. We're getting somewhere, uh, you know, somewhere a lot less. Let's put it that way. If I go up to 10, oh, every once in a while we get a few wins, but that's about it. What if I go up to 100,000? 20, 14, 22. Okay, so that's about 10. Like, you're seeing a little bit more fidelity or accuracy because we're running it more times. Again, remember the whole idea of Monte Carlo. Run it a whole bunch of times until you can kind of get a feel for the probability of the win. So if I go up to 1,000,000, this is actually going to take a little bit of time. It's going to be a bit sluggish depending on the speed of your computer. But notice I'm getting, again, a bit more fidelity. It's now, when it was 10,000, I was getting ones, twos, threes. I'm running 100 more times. And of course, I'm getting about 100 times more wins. But notice it's giving me some accuracy here. So this was, somewhere between 1, it looks like, and 2, probably less than 2. I'm not seeing much over 1 point, 150, I mean. So, okay, it's working. Monte Carlo's working. Monte Carlo doesn't work, just to maybe state something that's somewhat obvious, when I go to 100. I clicked run here, and notice it's really slow. You can kind of see it on the run button here. I click run, and then it just sits there for a while, and then it kind of turns a darker gray again. It's going to always be 0. Even with 1,000,000 runs, even with 10 million, even with 100 million. Remember what we said about playing 1,000,000,000 years worth of plays and still being super unlikely to win. Like, even if I put a lot of zeros here and you had your computer go do this for, the next, I don't even know how many, whatever times it would take. We could do the math, but we won't bother because that would be pointless. I don't want my computer doing this for the rest of its life. So this is just going to keep saying 0 no matter what. So Monte Carlo isn't perfect for computing odds. That's one thing to notice. It can't compute odds for really unlikely things that even computers have a hard time simulating over a reasonable amount of time. Fine. Okay. We didn't expect it to be good. Math is still useful. Yay. Computers can't do everything. We knew that, I think. So yeah, basically, Monte Carlo isn't perfect for anything, but you do realize, loops can take a lot of time. You do see this is actually taking forever to run now. Or not forever, but it's taking noticeable amounts of time to run. There we go, it stopped. If I down this back to 10,000, it's much more reasonable. I click run and you see the button immediately come back to the state it was in. We're still getting zeros and we can't tell the difference. But again, here we can, right? We can see that actually having lots and lots of students actually winning if there's only 2 students. So let's finish up with actually adding a percentage on the end of this rather than just having this number of wins so that we can get those probabilities computed for us.